Good evening, everyone. Shall we start?
Yes,
Yes,
please
madam.
go ahead.
Good.
So before starting, I kindly request all the participants that kindly mute your mics. Okay. So once again, a very good evening to everyone. Greetings of the evening to you all. A warm and cheerful welcome to each one of you for the ATAL AICT Training and Learning sponsored 6 days online faculty development program on design thinking and innovation organized by Department of Mechanical Engineering of Sant Gajanan Maharaj College of Engineering, Mahagaon. Once again, I kindly request all the participants that kindly mute their mics. So, today is the third day of our faculty development program, and for today's session, we have with us the renowned and esteemed speaker, Professor S. Srinivas Murthy, sir. On behalf of Sant Gajanan Maharaj College of Engineering, Mahagaon, I heartily welcome you, sir. Professor S. Srinivas Murthy, former professor, IIT Delhi. Welcome, sir. I also welcome all the participants for this FDP, and I'll introduce briefly about today's our esteemed speaker, Professor S. Srinivas Murthy. So Professor S. Srinivas Murthy received his BE, MTech and PhD degrees from Bangalore University approximately 1967. He has completed his BE. Then in 1969, he has completed his MTech from IIT Bombay, and his PhD degree he has completed in 1974 from IIT Delhi in electrical engineering. Sir served Indian Institute of Technology IIT Delhi for 42 years as a faculty as well as professor. His major administrative positions include Head of Electrical Engineering Department at IIT Delhi, Director of NIT, Surathkal and ERDA, Baroda, and Vice Chancellor of Central University of Karnataka. Sir is an exceptional researcher and innovator. Professor Murthy has contributed to over 300 papers, supervised over 100 theses, and holds 18 patents. 15 video modules of total about 500 lectures recorded at IIT Delhi are available online in YouTube and other sites. His pioneering work on self-excited and grid-connected induction generators had led to real-world field installations for renewable energy power generation. Speaking about the area of expertise, Sir has expertise in electrical machines, drives, power electronic, renewable energy, energy efficiency, and many more. Sir has delivered 200 plus popular and special lectures in India and abroad, especially Canada, USA, Japan, UK, Taiwan, Singapore, included 10 webinars. Sir has served in many committees of professional organizations, INAE, IEEE, IET, IE, ISTE. He has extensive outreach activities serving industry, government bodies, academia, and social organizations. Sir is also having the interest areas are electric machines, drives, power electronics, renewable energy, energy efficiency, and engineering education. So we are very honored and privileged to have such an esteemed speaker with us for today's faculty development program. And the topic of today's session will be applying design thinking for educators. So once again, I welcome our guest. I also welcome all the participants, and I request our guest, Professor S. Srinivas Murthy sir, to please start the session. Over to you, sir.
Thank you for the nice introduction, and I greet all the participants for this FDP program organized by the Sant Gajanan Maharaj College of Engineering at Mahagaon. And the topic is design thinking, which is very vast. And today I'm supposed to talk about design thinking for educators. And in my enthusiasm, I prepared about 110 PPT slides. But in this limited time, it is not possible to cover all of them. I will cover the most important aspects of this using these presentations. However, the participants can access these PPTs and they can have a wider view of these things. The subject, which is, as I said, is very vast. So, okay, we will start. Next slide, please. So, the objective of this session will be, by the end of the session, the participants will understand the concept of design thinking and design thinking principle in teaching learning process, identify and solve real classroom problems or institutional challenges, and know how to apply design thinking in teaching, learning, R&D, and engineering products. Next. What is definition of design? This is important. Design is the intentional process of planning, creating, and organizing elements to achieve a specific purpose, solve a problem, or produce something useful and meaningful. Design is also the process of imagining and planning how something should look, work, and function before it is made. So design is a process before some product is made. Okay, so that is the important process. So it combines creativity, functionality, and problem solving. Next slides, please. So academic definition of design from engineering perspective, there are different definitions. Design is to find an optimum solution of a problem after clearly defining an objective function. So that means you must define an objective function. What do you want to achieve? And then try to find an optimum solution for this. So optimum solution doesn't mean the cheapest solution or the best solution. So it depends upon various constraints. So one has to design a product to suit that objective function. So design is a creative process of specifying something that has not existed before. So this is something new you have to create and produce a plan by which it can be realized. So design is also a process by which you have to realize something. So engineering design is a systematic, intelligent process in which designers generate, evaluate, and specify concepts for devices, systems, or process whose form and function achieve clients' objective or users' needs. So this is one of the different engineering design. Engineering is a process devising a system, component, or process to meet desired needs, considering public health, safety, welfare, and global, cultural, social, environmental, and economic factors. Design is the process of conceiving and giving form to artifacts that serve human needs and improve human experience or quality of life. So design is the creation of an artifact in response to a need. It involves synthesis, analysis, and decision making to produce a feasible solution. Next. Now, one must be clear. So there is a difference between a scientist and engineer. Scientist finds how things work. Engineer finds how to make things work. Therefore, research is a continuous activity for both scientists and engineers, needing design thinking. This is what it is about, the concept of a difference between scientist and engineer. So the engineer has to make sure that whatever is made, they should make it work. That's what it is. Next, please. So what is design thinking? So you must have by now know design thinking is a human-centered problem-solving approach that focuses on understanding users, challenging assumptions, and creating innovative solutions through iterative experimentation. So iterative means you have to go continuously find out different alternative solution to your problem. So that is also centered to design thinking. Design thinking focuses on understanding people's needs and creating innovative solutions based on the needs. And it encourages experimentation and collaboration. Design thinking also encourages experimentation and collaboration. Next one. Design thinking is a method of solving problems by understanding people's needs first, then generating creative ideas, making prototypes and testing them. So you have to work out different alternative solutions to a problem and then come to what is the best possible solution for the object, for the necessary purpose. Next one, please. So key principles of design thinking are human-centered, focus on real users and their needs. So that means the human being is central to this design thinking. And next is creative and exploratory. So that means you should go on brainstorming different possible solutions of the problem and without any limitations. And then iterative, then we keep refining ideas through feedback and testing. So it is not a one-way process. It is basically a continuously iterative process with a lot of feedback obtained from the stakeholders. Next is it should be collaborative. It should involve people from different backgrounds and all those involved. All the stakeholders must be involved. So design thinking involves a collaborative process. And then design thinking is key principle is solution oriented. So in the whole process should try to converge to a solution, moves from problem to practical solutions. So that is the aspect of the design thinking. Next one. And there are typically 5 stages of design thinking process. There are 5 stages. One is empathize. That means you understand the user, their needs and challenges. Next, define. Clearly state the problem based on insights. What is the main problem? That has to be clearly stated. So if it has to be, if it has to have a good classroom, so you should define what are the parameters of a good classroom. Okay. Then ideate. That means you must generate solutions, a wide range of solutions, and then to pick up the best possible one. Then prototype. Then build simple, quick versions of ideas. So you must come to what among the different possible solutions you try to build one which is perhaps the most suitable one, and then test it finally. Try the prototypes with users and refine them. Test the prototypes and see how to do it. Okay, next, please. And design thinking used in several areas like business product development. It is used in technology. It is used in education. Used in healthcare. Used in government services. Used in startup and innovation labs. So there are, as you see, there are several places where design thinking is needed. Next. And why is it important? Why design thinking important? It produces user-friendly solution because since it is with feedback from the users, it has to be user-friendly solution, and it encourages innovation. So it should become. You should think of what is the innovative way of finding a solution, and it reduces risk through early testing. So that means any possible solution is tested first, and then so that when it is applied, the solution will be applicable to the given need, and it helps teams collaborate effectively. That means all those who are stakeholders who are involved in this thing, when they can collaborate, that is that collaboration is important. It can't be decided by one individual or somebody. It must be involved. That means every stakeholder will be involved in the whole process. Next one. How to apply design thinking for educators? Educators are who? Educators are the people who provide education, and who are they're not only teachers but also administrators, the managers, and various people. They are all everybody becomes an educator. So educators can use design thinking to improve teaching, uh, learning experiences, and classroom processes. That means what type of ambience to be provided, and what are the school level challenges, what the institution must provide to the students. And it helps teachers deeply understand students' needs and create meaningful, engaging solution. Because basically, finally, your target group will be the students, and they must be benefited. So all the teachers, the managers, the organizers, everybody becomes the important functionaries to make sure that student needs are fully met. Next one. And how educators can apply design thinking? Empathize, understand students deeply. That's very important. And that means understand student means what the teachers can do. He should observe students during activities, both inside the classroom and outside the classroom, conduct interviews or feedback surveys, make sure that whether students are happy with it or get their feedback, okay, and also talk to the parents, colleagues, and counselors. So if students have problem, counselors will provide the possible solutions, and the parents have to be interacted with, and also the other colleagues, and the other teachers. So all this is important. Identify emotional and learning barriers. That means the student is a human being, and with the multidimensional interests and several factors, both physical and mental factors, to take care of. So that means you create student persona, profiles of typical students you create. That's what the emphasis. Next one. So the define clearly, identify the problem. So that means turn observation into a clear, meaningful problem statement. You must say what exactly is the problem. For educator, this means identify real challenges, framing the problem from a student's perspective. Because students may say he's not understanding in the class, or he cannot absorb what is being taught, or he is not happy with the ambience in the class, or he has some problem with his peers or whatever. So therefore, there are several problems have to be identified. Next one, please. So then with that problem, you ideate, you create many ideas, possible, and then you think of the possible solution. Educated techniques, brainstorm with colleagues and or students, use mind maps, sticky notes, or quick idea lists, encourage wild creative ideas first. For example, you can introduce games, experiments, simulations, create group activities, use storytelling or digital tools. Nowadays, there are many outside solutions. Distance learning process are available, videos are available. So therefore, you can try out different possible solutions. So that will create ideas towards solving the problem. Next one, please. Then you think of a prototype that may create a possible solution, a low-cost version of your idea. Prototypes in education can be a redesignated lesson plan, a new seating layout, a sample worksheet, or a short 10-minute experiment, a classroom routine trial, or computer-assisted demonstrations or videos. So therefore, there are several ideas you can experiment with. That's what is the prototype means. Next one. And when once you create this, you test it, try it with students and get a feedback. You have a solution, you make a prototype, apply it to the students, and conduct and then conduct the activity in class, how teachers ask students what worked, what did not work, what's the reactions and engagement levels, refine it, and you try one solution, and then if you, based on the experience, then you refine it, and then you can replicate or repeat the process. Next one, please. Now, educators will be benefited with design thinking because there will be more student-centered teaching. So that way you're providing a teaching processes with students' involvement, not independent of them. Increase engagement and motivation, better classroom management, and effective problem solving, and that is the benefit. Then encourage creativity and innovation. That means you find the education process extremely interesting and creative, and it also helps in a better, very strong student-teacher interaction. Next one. Why you require design thinking in education after all? So because it helps educators to redefine classroom challenges, enhance students' engagement, a faster innovation in curriculum and pedagogy. So because, curriculum is not a static process, and curriculum is a continuous process. It takes care of several things because the subject, many subjects are fast changing. So that has to be um, taken care of. Therefore, that's why it is important for the continuously design thinking is important in education. Next one, please. And you reflect and application. And where can you apply design thinking? You can apply it in teaching, in mentoring, or curriculum design. So several aspects in which you can apply design thinking. Next one, please. Uh, Design thinking in education, teaching, learning process. Next one. So, what is the objective of education after all? For example, if you look at engineering, you have to first create good human beings. Next, you create good engineers. Then you create good subject engineers like mechanical, electrical, and so on in that order. So that should be the process. So that is the objective you must know. Next, please. So this is a big chart as well. What is the learning process? And it involves creating, evaluating, analyzing, applying, understanding, and remembering. So this is the process of learning process. Okay. So this slide gives you the details. You can go through it later. Next, please. What is success in education? What is success in education is global and self-learning is the goal. So the thing is, education is continuously self-learning. That is most important. Classroom and teacher inputs are just one of the things or a part of the things. So the 21st century is the century of knowledge. So you have an access to several sources to collect your information. You have flood of information available from different sources, not only from teacher or the classroom or the books. There are several, you have internet, you have a lot of webs, Google search and various things are there. So search engines are very vast. Therefore, today your whole process is multidimensional. Next one, please. And now one thing is, what is educated? Who is an educated person? So I have defined educated person with humility. He will treat all human beings as equal. He does not discriminate based on caste, creed, religion, language, region, race, gender, age, etc. And he must educated person must be a person of integrity, honest, ethical, disciplined, and obey the law. And he must be a good leader and a good follower. And he must be a good communicator. So you must think of why it is important is in every country, education is a big asset. Educated individuals, educated citizens is an asset to any country. And it is not the person who just knows something, but a person is also a good human being. In fact, if you look at the difference between different countries, in fact, if you look at India, compare with a few other newly developed countries like Singapore, Korea, or Japan, they don't have much resources. It is because they have created good human beings who have a reasonable amount of ethics, discipline, honesty, and so on. Therefore, I think, therefore, education is not just information, or education is just not examination. Education is to make a person a good human being. Next one, please. And what are the basic segments of education? Is knowledge assimilation, self-study, knowledge dissemination, teaching, and knowledge generation, research. All these things are equally important for this. Next one, please. So that means we are going from a Gurukula to Shishyakula. So earlier it was Guru who was imparting knowledge to the Shishya student. But today, with all the ICT revolution and so on, Shishyakula or, yes, we are. Hello, yeah. Why PPT is. Yes, I'm not finding the PPT here.
So we too can't see, sir.
Huh?
No, sir. No.
Yeah, okay. Next one, please. Okay, so that means now the thing is school of teaching to school of learning. Education facilitates student to learn. Education, not examination, must be the goal of university. Next one, please. Next, please. So the thing is curriculum design. That means create interdisciplinary project-based lessons, include real-world problems with contents and students. Then classroom management, redesign classroom spaces for collaboration and engagement. And assessment methods, use portfolios, peer assessment, self-reflection instead of only examination. In fact, assessment of students should not be only examination. There can be several ways in which a student can be assessed. Then student support, understand emotional or behavioral challenges, and then design personalized learning strategies for diverse learners. So involve teachers, parents, and students in thinking policies, infrastructure, communication needs. Next one, please. Now, what is the benefits of applying design thinking in education? So now, for teachers, it encourages creativity and flexibility, promotes empathy and collaboration, helps identify real classroom needs, leads to practical, effective teaching methods. This is for the teacher, these are the benefits. For students, let us say it builds problem solving and critical thinking skills, increase engagement and ownership of learning, and it fosters teamwork and innovation, and makes learning more meaningful and relevant. So student will not be working in silos. So he will collaborate with his classmates and together. So he learns together. Advantage. Next one, please. So an engineer of quality, a person who is an engineer of quality must have multi-dimensional personality. He must have a technical knowledge and skills, and he must have soft skills. He must have human qualities, integrity, ethics, discipline. And education must impart all the above. So it is not only domain skills, but also human qualities. Next one, please. And who are the stakeholders of education? As we know, stakeholder education are students, faculty, management, industry, society, and government. All of them are stakeholders for education. So all of them must be involved in any design thinking. Next one, please. So now, what do you mean by effective teaching? Next one. So effective teaching, there are types of teachers, I would say. A competent teacher. A person who is competent means he knows the subject very well. He is a competent teacher. Other one is an effective teacher. That means he delivers the subject very effectively in the classroom. So he is an effective teacher. Then another is a popular teacher. So that means a person is popular with students. Right? So students like him. He is a popular teacher. Another is a dedicated teacher, a person who is totally dedicated to his profession. Now, actually, but necessary condition is dedication is most important for any teacher, and he must have the passion for teaching. These are absolutely necessary. This cannot be compromised. So, teacher must use design thinking to make the process most effective. Okay, next one, please. Uh, Now, new paradigm is technology-assisted teaching learning. Nowadays, it is technology getting very It is getting very popular and effective using relevant software. You need techno-savvy smart classrooms. Online education with massive outreach will be common. That means it is not just a classroom. You can have online education where you can provide education to a large number of people of the masses. And how we conduct class in the new paradigm is a challenge. Design thinking must help. So, with this, the classroom, a teacher must be aware the students have access to other tools of technical inputs. So, a teacher must make his teaching learning process effective through this. This is also a process of design thinking. Next, please. And now there is also an experiment today. It's called a flipped classroom. Flipped classroom is conducted by students. Students go through pre-recorded video lectures and come to the classroom. So that means they are come prepared with sufficient background information by going through the video lectures. So class will be divided to small batches guided by a tutor, and they indulge in intense discussions to fine-tune learning. So it is not a one-way process from teacher to the student. It is the students who go on brainstorming on the subject. So this is supposed to be very effective. You need a band of teaching assistants who can run these classes. This is the new experiments on flipped classrooms. Next one, please. Education beyond classroom. No, it is just beyond. That's also the new process. Project, internship, co-curricular activities, social relevant activities, greening, tree plantation, professional society, seminars, technical student bodies. So they are education. That's also part of. Even a student can learn a lot by playing football in the games. But that's also a process of education. Next one, please. And now design thinking research. Research methodology. Um, en- Now, engineering research special features, types of research, processing of research, support system for research. These are all part of the research process. Okay, next one, please. Now, the research, why research? What is the goal of research? Actually, in Upanishad, there is a statement, Swadhyaya pravachanabhyam na pramaditavjam. That means goal of life for a student is continuous self-study and knowledge spreading. So, knowledge assimilation, knowledge spreading. This is one thing. That means research or knowledge generation is very critical, and that becomes a lifelong process of learning, etc. Next one, please. And what is research? Creative and systematic work undertaken to increase stock of knowledge, including the knowledge of humans, culture, and society, and use of this stock of knowledge to devise new applications. This is research. This is as defined by Wikipedia. Next one, please. And then for designing research, you have to write a project proposal. If you want to do research, you have to get some support from different agencies. So these are the list how to write your project proposal I have written here. Yeah, get the format, background, objective, state of art, networking, your potential, strength of institution, budgeting, bar chart, deliverables, references. So this is how you write a project proposal. So this is so you design your project properly. Next one, please. And what are the government funding agencies for research in India? There is this Anusandhan National Research Foundation, ANRF. Okay. So, what is ANRF? This is a new one which is for doing research. ANRF was established under the Anusandhan National Research Foundation Act. It was passed by the Parliament with the formal operationalization being carried out via the Department of Science and Technology. So it is envisaged as the apex body in India for providing strategic direction to research, innovation, and entrepreneurship across a broad spectrum of fields. The natural and mathematical sciences, engineering and technology, environmental and sciences, health and agriculture, as well as the interplay of science, technology with the humanities and social sciences. So ANRF supersedes the earlier body of Science and Engineering Research Board, which was established under the SCRB Act of 2008. So this is the latest law, 2023, Anusandhan National Research Foundation. Okay, next one, please. Why was ANRF created? It was created to strengthen India's R&D ecosystem. Because today, if India has to become a Viksit Bharat, research is very critical, innovation is very critical. Unless innovation, you can say, you look at the history of all the developed countries, it is only through innovation they have come up. Therefore, if India has to come up, so there must be research must be fully encouraged. For that, the ANRF has been created. India has recognized the need to move towards knowledge-driven economy, enhance research culture in universities, colleges. So education is not just a classroom teaching learnings, it is also the knowledge generation. Improve industry-academia linkages. Then reduce infrastructure and funding bottlenecks to align with goals of National Education Policy 2020 that emphasize research-intensive universities. NEP 2020 wants research-intensive universities. All in universities must be research-intensive. It must be multidisciplinary education, because now today most of the subjects are multidisciplinary. If you want to build an aircraft, several engineering disciplines are involved. If you want to build a wind turbine or wind energy system, you find it is multidisciplinary. Okay, you want to do an electric vehicle, it is totally multidisciplinary. There are several areas: electrical, mechanical, electronics, computers, and so on. So therefore, to mobilize public and private funding, because they think research, it can be both public funding as well as private funding research in a coordinated way. So it direct research towards national priorities and global competitiveness. So we must know what are our national priorities, what are the needs for the country. So accordingly, the research can be oriented suitably. So this act envisages a corpus fund of 50,000 crores for 5 years for research under ANRF. So this is the objective of creating this ANRF. Next one, please. Next. So what are the key objectives and functions that are listed here? Maybe I'll skip this, and you can go through this, and it is available in the website of ANRF, etc. Next one, please. So what is different? What are the expected benefits? What is different? Increase in institutional emphasis on research in state universities and colleges. ANRF aims to address infrastructure gaps in such institutions. Better industry-academia collaboration and private sector participation in research funding, which is meant to increase risk-taking and translational research. That means moving from lab to market. Because again, that's also a design thinking. How to take your research from lab to the market. More flexible and quicker funding mechanisms, reducing bureaucratic delays in research grant dispersal, and better coordination across research agencies and elimination of overlap, and more strategic alignment of research with national priorities rather than fragmented small grants. That means it is a coordinated. So one thing, it is preferable. For example, if we look at the areas, if you want a renewable energy or climate change issues or environmental issues or electric vehicles or space technologies. So it must be a well coordinated thing, not that just one individual doing his own individual research. It must be a coordinated research. That's why it is created. Next one, please. So now the thing is that if you want to do design thinking, if you want to do research, you must also know which are the sources of funding you must tap. So as I said, it started with ANRF uh, uh, under Department of Science and Technology. Then there is the Department of Biotechnology. There is CSIR, DRDO, DAE, ISRO, UGC, AICTE, MNRE, MIT, MSME, Coal Ministry, and Technology Development, TDB, etc. Okay, so there are several, but I think the emphasis is going to be on ANRF in coming future, hopefully. Next one, please. What is the steps of research? It is basically to advance the periphery of knowledge. First, we need to reach the boundary of knowledge. And how do you reach the periphery of knowledge? That means you must first study the literature. So that is, if you want to do research, the process is first study the literature and then go ahead. Next one, please. What is literature? Literature can be from books, e-books, publications, journals, technical reports, patents, book of abstract, thesis of predecessor, search engines, Google Scholar, etc. Next one, please. To equip for research, you must, yes, if you want to equip for research, you must be very good in the knowledge subject. So take advanced courses. You must have a strong mathematics foundation, strong simulation knowledge, experimental skills, and knowledge of fabrication. So all this knowledge is required if you want to have a design thinking for research. All these things are required. Next one, please. Variety, there must be a self-research or guiding research or sponsored research. There are different types of engineering research, for example, for an engineering teacher. Next one, please. Types of engineering research. Engineering research, it will be theoretical research, modeling simulation, experimental, or industrial, or a combination of above. So there is a very different types of engineering research is possible. Next one, please. Identifying a subtopic. That means you have to identify a research topic. It may be self-motivated, or it can be peer-suggested, it can be societal concern, it has to be industrial relevant, or solving an exciting unsolved mystery. So there are you identify a topic which are different types, and then to choose your topic. So that means design thinking research will include all these things. Next one, please. And what is the new outcome of it? Whatever research you do, something new has to come. What is new? It can be a new theory. It can be a new modeling and simulation technique. It can be a new application. It can be a new product. It can be a new process. It can be a simple or economic solution. It can be a new design process or a new experimental finding with new data. Okay. Next one, please. And which research and development parameters? Student projects, master's thesis, doctoral thesis, publications, patents, technology transfer, sponsored projects, consultancy. So these are all the different outcomes of research. They are available in all these modes. Okay. Next one, please. Now, networking is important for research. Research is again not just individual based. See, networking means you can have network with other universities, national labs or research centers, industry, society, connected stakeholders, network with alumni, network with foreign universities, international bodies, network with the international collaborations, okay, network with professional societies, student chapters. So all these things will become a coordinated research activities. This is again a design thinking. And then you must know whatever research you make, and a new outcome should be in the form of a good research paper. That's how it is reflected. So how to write a research paper? Right? It should include the title, author, abstract, introduction, main text, results and discussion, conclusions, acknowledgement, references, and these are the components of writing a research paper. So design thinking means how to write a paper. All these must be there. So how to design a research paper includes all these aspects and include all this thinking that goes into it. Next, please. And how to write a thesis. Again, research paper is different than how to writing a thesis. Thesis will consist of different chapters: abstract, introduction. Chapter 1 is introduction and chapter layout. Chapter 2 is literature review, and chapter 3 is main work done. Then you have different chapters on different topics. And ultimately, lastly, you come to main conclusions and scope for further work. And then end with reference and bibliography and appendix and list of published paper from the work. So a thesis, these are the components of thesis. So design thinking for research will include how to write a paper also. Okay, that must well write. This is the next one. And what are the technologies? Say you must know what are the upcoming technologies. Say like integrated transport, intercity, intracity, strategic technology like security, defense, space, atomic energy, aerospace. Today, security has become so critical. Drones, and several of the aerospace weapon system, etc. ICT, semiconductor technology, VLSI, intelligent and energy efficient buildings, factory automation, flexible manufacturing, applications of robotics, mechatronics, 3D machining, technology-based education, and literacy drive. Illiteracy is bane in many developed countries. Underwater robotics and drones. So next one, please. These are some aspects which we said. So as I mentioned earlier, maybe we should repeat. So these are the components of research outcome: student project, thesis, publication, patent, transfer, sponsored consultancy, etc. Next one, please. Design thinking in engineering. Design is a word commonly used. Next one. What does it mean? Building design, next graphic design, then fabrics design, then appliances design, or many more. So if you want to go for next, therefore, now, for example, this is the picture of a Terminal 2 building of Bangalore Airport. So what it contains? It consists of, it is all green garden based thing. Okay, so you will look at how much design must have gone into this. Okay, and design thinking must have gone into this. This just to give one engineering example. Next one, please. Okay, so this is, as I said, Terminal 2 at Kempegowda International Airport in Bangalore. India has it has many features, including gardens, art installations, and a forest belt. And it is called terminal in a garden because of its focus on nature and sustainability. Therefore, every engineering problem gives you enormous opportunities for design. Next one, please. Next. So, you look at, just to give an example, you look at the evolution of fans. What type of, how many fans have come up? Or evolution of two-wheeler vehicles. So look at how it has evolved and what type of designs have gone into this. So you just you can see what type of design thinking has gone into building these engineering products through evolutions. Next one, please. Next. So similarly with TV, so you compare how it has evolved. You can see from the oldest possible type of TV to the newest possible type of TV, what type of engineering design has evolved over the years. So this is just to give you a picture of the design thinking in engineering products. Next one, please. Similarly, look at furnitures. You know how the furnitures have evolved from the earliest times to present times. Next one, please. So, as you said, design thinking process, it involves observe, empathize, and research. The first phase helps you to identify needs and locate issues to be solved through observation and empathy. Understand, analyze, and define. Second phase of the process helps you to understand and define and analyze the problem area. Number three is ideate, alternate, and create. The third phase helps you to come out with several alternate, creative, innovative solutions to the problem. And phase 4 involves build, prototype, and detail. So that is the fourth phase. And the last phase is uh, reflect, feedback, and implement. That means after building prototype, you check it up in the field, then to improve further for refinement, etc. Okay. Now this is the phases of a product. You observe, understand, ideate, build, and reflect. So these are the stages of the thing. Emphasize, define, imagine, prototype, and test. These are a sequence of events of creating a viable product at the end. Next one, please. Ideation, source of design thinking. So one thing is nothing to existing, old to new, old golden back to existence. Then these are the things which is how to understand. Okay, next one, please. How to understand your branch of engineering. Hmm? Definition, know the wings, application of each subject, understand and interdisciplinary areas, know the emerging and future areas, and explore career opportunities. Okay. And next one, please. Some doubts and clarification. Science now these are some clear thoughts you need to have. Science versus the engineering versus management degrees. Type of institute, college, university, private or government. So these are the varieties in education. Okay, and location of the institute, specialization in degrees, and your marks, rank, and etc. etc. Okay, next one, please. India innovation ranking. Where do we stand in terms of our position in India? India is the 40th position in global innovation 2023. As per WIPO report 2022, India is ranked 7th position in terms of resident patent filing activity in the world. India is 7th in patent filing. India improved its ranking to 60th position in 2023 from 79th as per Network Readiness Index, NRI 2023 report. So this is where we stand in terms of innovation and ranking. Next one, please. Global Innovation Index, GII, India ranks 40th among 132 countries in GII 2022. India ranks first among 36 lower middle income group economies. India ranks first among the 10 economies in Central and Southern Asia. Okay? So this is where we stand. Ranking for India 20 to 22. GII is 22 in 40, and innovation inputs is 42. Innovation inputs is 39. So I think maybe now in 2025 it must have hopefully improved its global positioning. Next, please. Innovation strengths and weaknesses. What are the strengths and weaknesses for India that is listed here for you to just go through? Entrepreneurship policies, graduates in science, etc., etc. Maybe I think you can go through it at your friend. So these are the where we stand. What is the strength of India? What are the weaknesses of India in terms of innovation, etc. Next one, please. Okay. Now we go to indigenous technologies for Viksit Bharat. Next one, please. So these are the sustainable development goals as per United Nations. What are the goals of the society must be? No poverty, zero hunger, then good health, quality education, then gender equality, clean water, then afforestation, then decent work, and so on. So these are the things which have been listed. And next one, okay, next one, please. So the thing is, a sequence of this thing is creativity, inventions, innovation. So these are all the sequence of all the three are equally important. Next one. Where this creativity needs? Creativity needed in education, in our work, in our workplace, at product, and any domain. We need creativity in all the places. Next one. How innovation takes place. Success, creativity, idea, innovation, inspiration, and development. So these are the things where innovation takes place. Next one. See, these are just a sequence of how the mobile phones have come up. So earlier, primitive mobile phone up to the present day mobile phone with so many features. So you can say all this has come out because of inventions, innovations, as well as product development, design, and iteration, so on. So design thinking has gone all through. Next one, please. So this is just an example of a smart electricity meter. You just please think of the design process, the design thinking which has gone into development of this process. Okay, how it has developed it. Next one. IoT energy smart meters. So there are smart meters today which will help you to economize or optimize the energy. Next one. It's a remote control based BLDC fan. Nowadays, most of the fans are going to be permanent magnet brushless DC, this thing. So it is all remote control. You can have the thing, etc. Okay. Next one, 3D printing. This is again you can use design thinking for the final product process. Next one. A smartwatch. You can look at the lot of design which has gone into making this smartwatch. Just a few examples are given. What is the today which improves the quality of human beings. Next one, please. Vehicle monitoring system. You can see the type of instrumentation monitoring system in a vehicle is enormous today, and it makes the vehicle so much smart. Next one, please. You see, this is again a toll gate. Again, a new innovation. How it has been, it is getting GPS controlled and so on. Next one, please. So these are some of the like drones, high-speed vehicles, then high-speed trains, and so on. Nowadays, you have the vertical lift, vertical touchdown cars. So cars we can have a vertical lift, then move on the vertical touchdown without touching to the road. So that is the new things. So you can imagine what type of inventions and designs to go on to. Next one, please. This is again examples of design or automation or which has gone into new engineering products and processes. This is in agriculture. Okay. Next one, please. Okay, fundamental route in identification of new technologies. State of art, current status, problems in existing technologies, what are the future development and scope, and these are the things. Okay, next. Steps in engineering solutions. Next, please. Modeling, design, simulation, analytical critical studies, control techniques, optimization techniques, comparative studies, and development. Next one. Integration, experimental studies, and performance validation. And next. Okay. So now this is example how it has evolved from IC engine to electric motor. Earlier it was totally fuel based. Now it is electric based. Next one. Next one, please. Now electric power system, how it has evolved over the years. with there were 20% losses. Okay. Now this is, and then hydrogen. The future is going to be hydrogen vehicle, for example. So it is likely to be a green hydrogen. You need a green hydrogen, and then the vehicle which will convert from hydrogen to battery, and then from there to the vehicle. So this is an example of what type of evolution of design. Now air flying. Okay. Now the future is going to be all electric aircraft are likely to be there. So there is a lot of innovations and designs in building the aircraft and providing these products. Okay, that means we are going to have a solar aeroplane. That means we will have a prototype solar powered aircraft. That will be totally. This is the whole schematic of things. The solar panels will be there. That will convert the DC power, and then it will run the motor and the propellers, and then provide the motive power to the aircraft. So that means there is no fossil fuels involved. It will be totally electric and charged by this solar, and if needed, be by ground charging. Next one, please. All electric passenger airplane. Electric aviation took a big step forward in June 2019 when a Massachusetts-based airline announced it had placed the world's first order for a commercial all-electric passenger airplane. The Alice, a 3-engine battery-powered airplane that can fly up to 1,000 kilometers on a single charge, will be delivered to Cape Air in 2022. So the US airline. So you can see the design which has gone into this. Next one, please. Future vehicles will be hydrogen vehicles, solar vehicles, all-electric aircraft, autonomous cars, virtual cars, and flying cars. This flying cars is one of the things which is likely to come, which will require very limited, low infrastructure, take off and land. This next one, please. The fourth industrial revolution. The first industrial revolution was on steam. Next was electricity, because the 20th century was called electric century. Okay, and now next is computing, and next is cyber physical systems. So that is we are the process of the fourth industrial revolution. You can look at design thinking all through. Next one, please. Emerging and future areas: Internet of Things, machine learning, artificial intelligence, big data, blockchain, 3D printing, robotics, quantum computing. So these are the areas which will have a very enormous and revolutionary changes in the future of technologies. Next one, please. Data science, cyber physical systems, or virtual reality. Okay, next one. So mathematics and computing will have a major role to play in the coming futures. Next. Key domains for AI, ML, and data science will be there. These are not confined to any specific areas. AI, ML is usable in power and energy, communications, manufacturing, defense and aerospace, automotive and transportation, education, agriculture, healthcare and medical, and safety and security. You can see so many areas in which these are new areas are coming, and you will require design thinking all through. Next one, please. Then finance and stocks, warehouse and supply chain, retail marketing, real estate, media and entertainment, smart cities, government and law, service providers, R&D, innovations, and patents. Okay, next one, please. So technology focus, these are the parameters: novelty, low cost, scalability, reliability, durability, functionality, user-friendly, low weight, unique features, efficiency, robustness, simple, low maintenance, new design, comparison, add-on to existing, testing, customer adaptation, creativity, and commercialization. That's the whole process of technology-based focus. Three important learning is continuous learning, self-learning, global learning. Okay. Next is to become extraordinary, out of box thinking for problem solving skills. So this is important. This is a design thinking. Or you must have out of box thinking. Then mentee skills. So you require have your mentor through professional life. So mentoring is important. That's part of education. Training, motivation, advice, success, direction, coaching, then support and goal. So mentoring has these features. So that is will be one of the features of the future. Next one, please. Opportunities and types. Next one. Uh, the opportunity will come and knock your door. You need to search long way and get the opportunity. Sometimes call for opportunities. You need to come forward and apply. Plenty of opportunities around you always, but those are invisible. But still, you should identify and grab them. Sometimes call for opportunities, first come, first served basis. So these are the aspects. So I have closed my lecture now. All the I run through all the slides, and now we can have some time for question answers session now. I think I've run through some of the things like I thought it can go through, but I would advise you can go through the PPTs and introspect yourself from your end. Okay, thank you very much.
Thank you very much, sir, for the enlightening session. Am I audible to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, madam.
Yes.
Okay. So, as per the objective, sir has spoken, by the end of the session, I think all the participants are able to understand the concept and process of design thinking, apply design thinking principles in teaching and learning, identify and solve real classroom or institutional challenges, and know how to apply design technology in teaching, learning, R&D, and engineering product. Thank you so much, sir, for such an enlightening, knowledgeable, and informative session. Now the platform is open for all the participants. If you are having any questions, doubts, and queries, then feel free to ask the doubts and queries.
Good evening, everyone. Good evening, sir. I just wanted to thank sir a lot because today's talk was very, very informative. It was in depth also, and sir addressed various issues. And very important of this is we are all almost everybody is in education. Whosoever participants are here. So how education is primarily could be applied in any institute or any teaching learning organization, that is a very different perspective which sir has explained here. So thank you so much, sir, for that. It's great sharing by you. Thank you so much, sir.
Okay, thank you. If there
Does
are no
anybody
questions,
have any?
Hello,
hello?
good evening, sir.
Yes.
Hello, good evening, sir. Sir, as a teacher, there is a one big task to teach the students because in previous years, means the back students before the COVID and after the COVID, there is some differences present in the students. So it's a very difficult task to the faculty to teach the students. So which type of the method will be used for this kind of the students?
Um, now, for teaching is a challenge for you. You are the teacher, so you must try to think how to make your class interesting. So I think the process of teaching and then also you encourage them to learn also. Okay. So that means you tell them that they should have a freedom to access the books and other materials on the subject. Okay, and then you interact with them. I think now, as I said, the future is going to be Shishakula and not the Gurukula anyway. So I know it is a challenge. That means it requires a lot of interaction between the teacher, students, and the teacher. And what do you want to deliver? That is important. That means at the end of the class, is the students going out with any what has they learned from the class? Okay, so that is one thing you must introspect yourself. Okay, therefore, I mean, I think it is very difficult to give a single track solution to a teacher. A teacher himself can do a lot of experiments in his teaching processes, and out of box thinking for problem solving. That's what it is. You must know there are a lot of challenges in sense. There may be students with different levels of comprehension. Say they come from different backgrounds, social, economical, and so on. So maybe all these things will be an issue. And are they interested to learn? That is another challenge. Are they Vidyarthi? Vidyarthi means the person who is interested in Vidya. I think you may have to think of all these things. So our design thinking is multi-dimensional that way.
Okay? Yeah, right, sir. Okay, thank you, sir. Thank you.
Okay.
Hello. Good evening, sir.
Hello, sir.
Hello.
Yeah.
Good evening, sir.
Sir,
Yes.
Hello, sir.
regarding Gurukul and Shishyakul, is there any Shishyakul available at the moment? Gurukuls, we have heard that a number of Gurukuls were there in ancient India, but is there any Shishyakul type of any institution is available?
Yeah, I think there are many institutions have tried to involve, because it is not that one type of school is a Gurukul, another type of school is Shishikul, etc. For example, there are some schools started by J. Krishnamurti type group of institutions. Some of these Sadgurus, etc., and even some of the educationists are experimenting with the new methods of education. Now, another thing is you see the flipped classroom, which I just mentioned, where the students will be first asked to go through the video lectures of the same teacher or some other teacher, and then they ask them to come to the class. And in the class, let it be a discussion sessions, and that means the students will go on debating, brainstorming on the subject. Supposing you said I am going to discuss about electric motor. So let them collect all the information they know about from this. In the class, you brainstorm on that. So there it becomes, and so teacher becomes not just idea giver, knowledge giver. He also becomes knowledge refiner for the students. Now, I agree. This requires lot of support from the management and the institutions, and the present methods of examinations, curriculum, syllabus, and examination, etc., are very outdated in my personal view, etc. So if you look at how the universities in developed countries like Europe, America, and Japan, they work. I mean, there is lot of innovation and thinking process. Are we making our students thinking? This is my. But recently, just about last week, N.R. Narayan Murthy gave an interview with Arnab Goswami in TV. He was saying main difference. When our people go abroad, they do very work. They are very sincere, very dedicated, very disciplined, etc. But they are very less innovative. Why is it so? That means we are in our education, we seem to kill the innovation skills of the students. So I think if you give the Shishya-Kula, there will be more innovation skills coming. Students can come out with their own ideas of the things. Are we allowing that to happen? No. This is, I think you as teachers, you must go on thinking about it. Are we making the students to think or innovate? No. So that is the Shishya-Kula. Okay.
Hello, sir.
Okay. Yes.
Hello, sir.
Yeah.
Good evening, sir. Nowadays, the education system. Hello.
Because we hired to the students.
Yes.
Hello.
Yes.
Good evening, sir. Nowadays, in market, the education field is looking as a one business, or it is a just like a commercialization.
Yes.
No doubt. So how we will balance it? Because in olden days, some ethics, some principles are applied to the students, just like a Gurukul system means that the students having some respect, that is the fearful respect towards the teachers. And nowadays there is no anywhere respect and no any value to the teacher. Also, the society is also looking towards the teacher as a one ideal teacher, but the teacher facing a lot of problems, just like a mental, economical. Then in that critical condition, how we are just a young teachers, not olden days teachers, but in this critical condition, how we will survive and how we will balance the that all conditions to motivate the students or to survive from these just critical waves.
I totally sympathize with you, and I'm totally with you. Let me tell you that. So the thing is that we have to refine our education system totally, and it cannot become a sort of a commercial commodity. Education, education is not like a selling tomato or potato or whatever it is. Therefore, I think that first thing is society must respect the teachers and the and the teachers, and it is extremely shocking that many universities they are not filled more than 70% of the sanctioned strength. Okay, number one. Number two is they want to run through the so-called guest faculty. They call it as guest faculty, and who are not made permanent for decades. Therefore, I think one has to tackle this fundamental the problem which has been created by the policy makers. Okay. Therefore, you cannot have, because if you say, I would say the so-called guest faculty is like a bonded labor, and which is then where is the respect for the teacher? Okay. Therefore, I think and there must be a concerted effort in this so-called refinement. The NEP 2020, National Education Policy, have many positive goals, but that has to be understood by all stakeholders. As I told you in my slides, stakeholders are the government is a stakeholder, society is a stakeholder, parents are a stakeholder, and management of the institutions are stakeholders. Everybody must have the same goal to give the best possible education. Otherwise, unless we give very good education, you just can't expect India to become a Vikasit Bharat. Education and research are very central to the development of the country. And even recently, I saw an article by Ram Gopal Rao, former director at Delhi and now in charge. He clearly said the government funding is very critical. You cannot, to make our education system really of international standard. Therefore, that is where it is You know that I would say for best education, 3 F's are important: funds, faculty, and freedom. 3 F's. Unless you have these 3 F's, I mean, we will suffer. Okay. Therefore, I sympathize with you. I agree with your ideas, but we should all try to find a solution to this. This is where design thinking must help. Okay.
Okay, thank you, sir. I tell to you here one thing. Just I wrote one article in Marathi. That is the heading is nothing but the same for the topic. Just like Shishya is converted to student and Guru is converted to sir, and that is the whole old situation compared with the present situation. Means the education field or education business is going to in which direction, and what will be the adverse effect on the our society or the next generation. That is mentioned in my that special article, and that article is published in many books, sir, also in Marathi. Thank you, sir.
Good. Very good. No. But the thing is, the fact, just like you are publishing, the teachers who are sincerely want to improve the education, they should express their views like you. You should express the views. And more, the problem is in most of the times, you know, we just keep quiet. अरे हमारा क्या है, मुझे क्या मिलता है, you know, ऐसा type. So unless the educated people express themselves, and then things won't improve. Okay.
Okay, thank
That's
you, sir.
what it is.
Hello.
Yeah.
Good evening, sir.
Yeah.
Sir, one more question from my side is that in my university curriculum, creativity, design and thinking course is added to the third year students as per the NEP. So my question is what we should expect from the student as the outcome of this course, or how we can assess that course, sir, at the end of the semester?
That is, you know, assessment is a tricky process. You see, you can see whether they have inculcated design thinking in any of the given problems. What is the, see, as you said, design thinking is a process of finding a suitable solution. Whether they have been able, you throw them a problem and let them come out with a solution. Okay, as you know, Mr. Deshpande has said recently, that means there is a problem in education. Then let them come out with a solution. Unless they come out with a solution, they're not design thinking. Okay, so that is what should be there. And already we have told the process in which you should find a solution. Okay, so throw the problem and let them find a solution, and that's how we should assess them. You know, nowadays there is a hackathon, all the things are there now. Yes.
चार्जर पण कुठला
Yes.
Hello, sir.
Yeah.
So in the current semester, what we have done, sir, actually, we given them a real-time societal problem to the students, and as a practice, we try to, or we are convinced to them, prepare the canvases for their problem statements, like you should go for the problem statement canvas and problem framing canvas, or you can go for the empathy canvas. So what the solution you will get from that, so present that. So this is the procedure we have followed in the current semester.
Good, very good. Yeah, I think you pursue this in the process. That's all. Yeah.
Okay, thank you, sir.
Okay.
Sir.
Yes.
Hello. Sir, in the process of implementing the design thinking during the class, okay, so which type of teacher competitive, effective, popular, dedicated? So which teacher quality has to be attained, sir?
No, I didn't get you. What teachers has to do, is it? Hello?
Yes, sir. Yes, sir.
What teachers have to do?
Sir.
Huh? And teacher has to experiment. That's all. He has to think. He has to interact with students and try to get a suitable solution to a problem. That's all. Okay. In education, what is it? Education is how you are making your teaching learning process most effective. That is the objective, no? Teaching learning. So you throw the problem and get a solution. Okay. Okay. Hope there are no other problems and no other questions.
Any other questions from the side of the participants? I think sir has cleared all the doubts and queries of all the participants. Once again, on behalf of Sant Gajanan Maharaj College of Engineering, Mahagaon, I express my heartfelt gratitude to Professor Srinivas Murthy sir for attending the session and giving us that enlightening and thoughtful knowledge regarding the applied design thinking for educators. So once again, thank you so much, sir. And I request all the participants that kindly on your webcam just for 2 to 3 minutes so that we can click some snapshots. So participants are requested that kindly start your webcams just for 2 to 3 minutes.
Anyway, thank you very much. I enjoyed this interaction. It was very
Thank you
good.
so much,
And
sir. Thank
thank
you
you
so
very
much,
much.
sir.
Thank you very much. Thank you. Namaskar.
Thank you. Thank you, sir. Okay, so I think we'll take 5 minutes break and immediately as soon as our next speaker will join, we'll start the session. So stay tuned and take 5 minutes break. Thank you, everyone.
Okay, so I can leave now. Thank you.
Once again, thank you so much, sir.
Okay, I will
Sir,
leave. Okay,
you're
thank you very
welcome.
much. Okay, right.
Thank you, sir. Thank you,
Yeah,
Parag.
thank you.
Good evening.
Good evening, sir. Participants are requested that our next speaker, Dr. Sridhar Kondur sir, has
Good evening,
joined
sir.
the session. So within 2 minutes, we'll start our second session. So all are requested to join the session immediately. Hello, am I audible?
Yeah.
Yes, ma'am.
Good
You
evening.
are audible.
Yes, ma'am. Audible.
I welcome all the participants and today's renowned and esteemed speaker, Dr. Sridhar Kondu sir, for the next session. The topic of the session is design and prototyping. So on behalf of Sant Gajanan Maharaj College of Engineering, Mahagaon, I heartily welcome Dr. Sridhar Kondu sir for the session. And last moment, sir has agreed and accept our invitation. And thank you so much, sir, for accepting our invitation. And now if I'll briefly introduce today's our esteemed speaker, Dr. Sridhar Kondur sir, Professor of Mechanical Engineering and Innovation Strategist, St. Louis University, USA. Uh, Speaking about the education details of sir, sir has completed PhD in Mechanical Engineering in Texas A&M University, USA. Sir has completed MTech in Design Engineering, Indian Institute of Technology, Bombay, and sir has completed BTech in Mechanical Engineering, Jawaharlal Nehru Technological University, Hyderabad. Uh, Speaking about the area of expertise, sir has expertise in design theory and methodology, sustainability, etc. Entrepreneurship and innovation educator with over 30 plus years of experience helping students and faculty think creatively, act entrepreneurially, and lead with impact. Creator of programs that blend design thinking, innovation challenges, and experimental learning, adapted for global and Indian context. Speaking about the key highlights, sir has been the founder, Weekly Innovation Challenge, engaged 1,000 plus students in hands-on innovation, leader, Dynamic Compass Network, grant to build entrepreneurial mindset, creator, Impactful Classroom Series, trained 250 plus educators to integrate AI and design thinking. Sir has been the board member, SRIX Technology Business Incubator, mentor and workshop facilitator, delivered GEM, Growing Entrepreneurial Mindset, and Tinker Campus across US and India. Sir has also mentored student teams to international innovation awards, and today we are very honored and privileged to have such a renowned speaker with us. Sir will speak with us on the topic design and prototyping. So once again, I request all the participants and our today's esteemed speaker, Dr. Sridhar Kondur sir. Welcome, sir, and I hand over the session to Dr. Sridhar Kondur sir. Over to you, sir.
Thank you, ma'am. Thank you all for attending. I graduated from JNTU long time ago, 1988, kind of tells you, and left to US. So I've been here for a long time, 30, close to 40 years. And I come to India regular basis and try to help give back in some way or other. So that's how the GEM workshop, the Impactful workshop series, all of them came into existence, where I do faculty training. I see faculty development training like the one you are attending is very impactful, because if you even pick up a little bit, it would impact a number of students. Okay. My goal here is to give a broad overview of give me 1 second, I'm trying to share the screen. So my goal here is to kind of give a big picture overview and take you through a simple example of how to the design prototyping works. Okay, so let's get started without any delay. Okay. Just want to make sure everybody can see my slides.
Yes.
Yes, sir.
Yes, sir.
That's awesome. Okay. So typically, this is a fairly long workshop for different aspects. This particular part of the workshop is the design portion. So I'm going to condense it to just focus on design prototyping. So I may go through a bunch of slide decks, but the goal is for you to see a big picture. So probably
ठीक है, इसको
by now,
चिपका दिया था क्या तुमने प्रेस से? ये काला काला कैसे हो रहा है?
can somebody mute the, okay. Probably you got exposed to the Stanford model of design thinking in the previous sessions. Primarily, the Stanford model goes through these 5 steps. First step is empathize. So empathizing is understanding the needs of the people, understanding how they feel it. Then you define the problem or define the scope, what you want to address. Then you come up with ideas, you prototype, then you test. So when we say design in a large context, design encompasses all of them. And sometimes we say the design is we empathize, define, and ideate. This part is the design portion. Prototype testing is the second part of the process. So it could be, depending on how you talk, design means different things to different people. For example, interior design is a design also, mechanical engineering design. So there's so many aspects to the design portion. And in terms of general design thinking, these are the 5 steps. Okay. So let's kind of figure out what we will do today. First one is I want you to kind of learn a little bit about brainstorming. So I have a huge slide deck, but I will go through a few slides so you understand what brainstorming is. Brainstorming tells you to understand the pains of the users. So that helps you to come up with products that actually have value to the customer. Okay. And the important word I use right now is the value, because customers pay money if they see value, and businesses can survive only if we have paying customers. So the value is a critical component when you are designing. So all the time think about design. The word value you may not see often, but value is underlying thing you are trying to address. So the first one section we talk about is brainstorming, which would help in empathizing and defining what needs to be done. And ideation, there are many ideation techniques. There are hundreds of them. Okay, I would talk about one technique, Scamper. That way you kind of know, hey, there are many techniques. Scamper is something that is easy to use. I can do this. And then we'll talk about prototype. Prototyping is useless unless you test it. So they go hand in hand. When people say prototype, they're doing prototyping and testing. So the next section is testing. And we'll tie all these 4 sections with a integrative example that cuts across all the 4. Okay. So that's essentially the outline of our presentation. So first is, if you are designing anything, you want to find the pains, then you come up with ideas, you prototype, you test. If testing tells something needs to be changed, you come back and change the idea, or you may find new pains and you may iterate, you may go back and forth. The way it's described looks like linear process. It's quite non-linear. You go back and forth quite a number of times between prototype and then you basically see the integrative. So with that, let me change the slide deck a bit. Wrong slide deck. That's our university colors, brand colors, blue. So we always call St. Louis University blue color. So it's a pretty place. So the goal is pains and gains. Storming. So our goal is to find what are the pains, what are the gains. Okay. So people think about what's a pain, what's a gain. I'm assuming that most of you are middle-aged because you are faculty, you graduated. A lot of time people start taking vitamins in the middle age. So vitamins, why do you do? You don't have a headache or anything. You take vitamins because it will keep you healthy. So that's a gain. And pain is, you have a toothache, you go to the dentist or you get a uh, painkiller, use the painkiller. So essentially, Tylenol would be considered a pain killer, I think. And today we'll just talk about the pains. Gains are also important. Why I'm focusing on the pains is because people always are willing to pay money to solve their pains. For example, you want to go to a movie, okay, and you have all the plan to go to movie, but unfortunately, just before going to the movie, your teeth start hurting. Would you go to a dentist or a movie? Definitely, you will go to the dentist. Same way, uh, people are much more open to open the wallet, spend the money to address a pain than a gain. So it's important to know what the customer pain points are. Pain points are sometimes easy to find, sometimes difficult to find. Okay, so there are a lot of words here, and basically what it tells you is um, people kind of live with pain and they don't know that they have pains. Those are unconsciously they think this is the way world goes and there's no a better solution. When I was doing my PhD in IIT, we used to submit the card deck for the computer and wait for the next day to find out what went wrong. Okay, so we thought that's the way things run until we figured out we can do all the computation on our desktop or on mobile phone now. Okay, so always you designers look at what are the pains, what can I address. This picture was taken on Godavari, somewhere in Andhra. So this particular one, people think about fishing in the river. So I took this picture where I was going down because you see two people. One is trying to get the net out. Another person is trying to row. Okay. So rowing is a painful thing, but they may not say it's painful because if you want to fish, you need to row. Spreading the net is wide is difficult. It's often two people job. Okay. As I was going down the river on the riverboat, I found a bunch of coconut, not coconut, sticks sticking out from the water. Okay. And you see birds sitting, all of them. I was thinking somebody was nice to put these sticks so that birds can have a resting place. Okay. Kind of weird. Then the real purpose is people come, people tie the boat to both sides. Okay. And spread the net and wait for fish to come in. And if you see, there's only one person here, not two people. He rows the boat. He doesn't need to do anything once he put the net and wait for people to fish to get in the thing. So what the mindset changes, we don't take as designers pains are granted. Everything could be changed. We just need to find a clever solution. This clever solution, what it does is it eliminated the pain for the person to row. Keep dragging the net, eliminated it. Then instead of each person earning, two people earning this money, here each person is earning the same amount of money and they can relax also a little bit. Okay. And that's essentially what a design thinking does. Okay. So let's focus on the word pain point. Pain point is a problem experienced by customer in getting a job done. Okay. This picture, you see millions of men, women, mostly women, girls spend enormous time getting water. This happens in India, this happens in Africa. There was actually an ad from India, Amazing India, or Incredible India, where women were carrying water on their head. Okay. So that was pretty thing. So you think about it, it's pretty heavy on the neck, it's back-breaking, it can cause quite a bit of injury. You talk to the women, they will say, hey, My mom did it. My grandmom did it. I'm doing it. It's just the way things are done. Okay. But the problem is, grandmom walked maybe 100 feet. Mom walked 1,000 feet. These people are walking miles. Okay. So the pain kept growing. And people think that's the way things are done. We don't change. So these pains, if we can recognize, we can come up with a really innovative solution. Okay. So you have a solution called Q-drum. Somebody came up with this idea. Okay. Here, a little kid is pulling that thing with a rope. We're not encouraging child labor. We are just telling that it's so easy that a kid can pull. Okay. Villagers, this drum can hold about 50 liters, durable, no handles, nothing. So rope can easily, so they can pull it and get the water without all that back. So that's essentially what a brainstorming is. Okay. So let's think about gains. Gains are things that are delighted, that are unexpected. And gains are also selling point, but that's not the focus of this. I'm just telling you so you have the complete picture. Okay. I will talk about example of a design engineering one. Helicopter. Helicopter was done by, I guess, Sikorsky. When the Sikorsky was trying to design the helicopter, okay, he needed to sell this idea to people to say this is a wonderful invention. So, but there's already airplanes which can do similar job. So how can I address the pain points that the airplane can't address? So you have to distinguish. So the way he said is, if a man is in need of rescue, if somebody is in trouble, have a heart attack, something like that, then a plane can come, throw flowers, but they can't rescue. But a chopper can go pick him up and take him to the hospital. So that's essentially how this particular device could address a problem that other competitors couldn't address. The competitor being airplanes. Okay, that's how you start thinking about what is that pain that my product can address, nobody else can address. Okay, and you think about everything. For example, glasses, keychains. Okay, glasses. The paints are they scratch easily, they break easily, they are fragile. You come out of AC room, everything condenses on the lenses, and you need to change long distance, short distance glasses, things like that. Okay? But we live with all these pains. If only we say, hey, these are the 2 or 3 biggest pains, and we will address in our design, world would be a lot better. Yeah, well, let me see how I'm doing on my time so that, let's go. What I will do is, I'll do a couple of things. For example, women have hair bands. They lot of pains associated with it. They break, they lose elasticity over time. The biggest pain this particular product addressed is ouchless. Ouchless is the metal clip is not there, so it never pulls your hair off. Okay. Ketchup. Ketchup bottles were very popular, even popular now. But if you think about ketchup bottle, there's so many different pains. Okay. One pain is it's difficult to open. Okay. It is difficult to get a right amount of ketchup out of the bottle. Okay. When you want a little bit, lot comes out. When you want lot, little comes out. Okay. If it rolls. Sometimes it rolls and falls on the ground, breaks. Okay. And if you ever look at the cap of the bottle with the lid, it looks so bad. Can we even use this ketchup bottle kind of feeling you get? Okay, because all the ketchup dries out, fungus is growing, things like that. So what designers came up with a fairly simple innovation, that is bottle upside down, you squeeze it, the right amount of ketchup comes out. So you have a control on the ketchup portion of it. Okay. People lived with the first bottle for almost several decades before coming with the second bottle. If only we can think about what the paints are, engineers would be a lot better and more efficient. That's essentially the empathize part of it, and saying what are the pains worth solving. I want to talk about the shoes for little children. Little children have trouble distinguishing between shoes for the left foot and the right foot. So sometimes they wear the left shoe on the right and right shoe on the left. Okay, think about you are going to a party and you have a little kid who wear the left one on the right one on the left. You tell that, hey, left should go on the left and right should go on the right, and he takes it out, puts it back wrong way, and you are in the pressure to go to the party on time. You yell at the kid, and the kid start crying, and it ruins the whole day. What did the shoe companies do? They put a big L, big R, big L for left, big R for right. But the problem is, it is not the kids don't know how to read, but the problem is they don't know which one is left, which one is right. They have good eyesight; they can see little L's also. Instead, somebody came up with a really smart idea, which is very simple. These are stickers called shoes. So you take this sticker, put the left one in the left shoe, right one in the right shoe. Okay, kids know to make the cow or a pig or a sheep, you just need to make sure that the right one goes there. So if only we can come up with products that would help customers solve their pain, would be much better shape. Okay, the inventions don't need to be complicated. All they need to be is very simple. Okay. Let me skip some things. So how do we identify these pains and gains? Brainstorming, gainstorming is like brainstorming. You sit with friends or colleagues and say, here is the task we have to do. What are the pains associated with it? So if we can come up with a number of pains, that would be good. The second one is product reviews. Product reviews, you go to Amazon, look at the reviews. You look at reviews of forums and see the reviews of different products that provide some insight. Okay. Customer interviews are much more time consuming than the first two, okay, because you have to go talk to the customer, but nothing replaces talking to the real customer. So talking to the customer is much more difficult, much more time consuming. The last but not the least is customer observation. That means you sit and just watch them do stuff. So you see what they're doing and see is there something can make them do better. And these observations are probably the maximum time consuming, can run into weeks, months, and we think all humans are alike, but they have individual preferences, and you need to figure it out, your target customer, and figure out what their preferences are. Okay, because I was talking to the Indian audience, I picked up a video that I thought would be a nice one for you to watch. It kind of gives you a sense. I hope this works. Can you hear the music from the video?
No, sir.
Can't hear the music from the video. This is a problem. Let me see.
Forward to was played in India.
Now also no?
Yes, sir. Now it's audible.
Okay, that's good.
In India, we have these huge families. I bet a lot of y'all must have heard about it, which means that there are a lot of family events. So as a child, my parents used to drag me to these family events. But the one thing that I always looked forward to was playing around with my cousins. And there was always this one uncle who used to be there, always ready, jumping around with us, having games for us, making us kids have the time of our lives. This man was extremely successful. He was confident and powerful. But then I saw this hale and hearty person deteriorate in health. He was diagnosed with Parkinson's. Parkinson's is a disease that causes degeneration of the nervous system, which means that this person who used to be independent suddenly finds tasks like drinking coffee because of tremors much more difficult. My uncle started using a walker to walk, and to take a turn, he literally had to take one step at a time like this, and it took forever. So this person, who used to be the center of attention in every family gathering, was suddenly hiding behind people. He was hiding from the pitiful look in people's eyes. And he's not the only one in the world. Every year, 60,000 people are newly diagnosed with Parkinson's. And this number is only rising. As designers, we dream that our designs solve these multifaceted problems, one solution that solves it all. But it need not always be like that. You can also target simple problems and create small solutions for them and eventually make a big impact. So my aim here was to not cure Parkinson's, but to make their everyday tasks much more simpler and then make an impact. Well, the first thing I targeted was tremors, right? My uncle told me that he had stopped drinking coffee or tea in public just out of embarrassment. So, well, I designed the no-spill cup. It works just purely on its form. The curve on top deflects the liquid back inside every time they have tremors. And this keeps the liquid inside compared to a normal cup. But the key here is that it is not tagged as a Parkinson's patient product. It looks like a cup that could be used by you, me, any clumsy person. And that makes it much more comforting for them to use, to blend in. So, well, one problem solved, many more to go. All this while, I was interviewing him, questioning him. And then I realized that I was getting very superficial information or just answers to my questions. But I really needed to dig deeper to get a new perspective. So I thought, well, let's observe him in his daily tasks, while he's eating, while he's watching TV. And then, when I was actually observing him walking to his dining table, it struck me, this man who finds it so difficult to walk on flat land, how does he climb a staircase? Because in India, we do not have a fancy rail that takes you up a staircase like in the developed countries. One actually has to climb the stairs. So he told me, well, let me show you how I do it. Let's take a look at what I saw. So he took really long to reach this position. And then all this while I'm thinking, oh my God, is he really going to do it? Is he really going to do it without his walker? And then and the turns, he took them so easily. So shocked? Well, I was too. So this person who could not walk on flat land was suddenly a pro at climbing stairs. On researching this, I realized that it's because it's a continuous motion. There's this other man who also suffers from the same symptoms and uses a walker. But the moment he's put on a cycle, all his symptoms vanish because it is a continuous motion. So the key for me was to translate this feeling of walking on a staircase back to flat land. And a lot of ideas were tested and tried on him, but the one that finally worked was this one. Let's take a look. He walked faster, right? I call this the staircase illusion. And actually, when the staircase illusion abruptly ended, he froze. And this is called freezing of gait. So it happens a lot. So why not have a staircase illusion flowing through all their rooms, making them feel much more confident? You know, technology is not always it. What we need are human-centered solutions. I could have easily made it into a projection or a Google Glass or something like that. But I stuck to simple print on the floor. This print could be taken into hospitals to make them feel much more welcome. What I wish to do is to make every Parkinson's patient feel like.
So what that video should highlight. Now let's go back here. So what happens is when you're doing brainstorming, brainstorming, if you are able to do it with professionals, you may get quite a bit of insight, product reviews you get, but nothing can replace actual customer observations. Because customer observations are untold pains, like the boat rowing the boat. They think it is part of being Parkinson is shaking. Part of fishing is you need to row the boat. Okay. So when you observe for longer time, you would be able to get more insights. So the key I want to talk about is find out the pains and pick one or two pains you would like to observe, address. In this particular case, the lady addressed, okay, I want to take care of tremors, drinking coffee, moving through a staircase effect. Okay, she was not trying to solve the big problem, she was trying to solve the individual problems. Okay. So the next, what I want to kind of go through very quickly. Once you identify a pain, you start thinking about a method called Scamper. Okay, Scamper is basically a multi-purpose tool like a Swiss Army knife. Okay, and it helps you to generate a many novel ideas. Okay, first one is substitute. Substitute is you are substituting something with something of more value. For some reason, this keeps. Let me get this my screen here. I used this last time. I put it in auto transition that I did not take it out. Okay. So you are substituting something with something else. For example, we started with Matchbox and we got lights, CFL, LED lights, and the lights keep progressing. And while you are progressing, you are using lesser and lesser amount of energy, and we are spending less money. So it has both environmental value and also economical value. So think about what can I substitute, the product or the process or the material? Can I do a quick substitute? If I can substitute, that would be the easiest thing. Think about substitutions. Okay. Think about once upon a time, we used to go search for literature in library. Okay. Google substituted the library searches on Google. Now AI came and AI is substituting Google searches, and we are able to do literature search with AI. So everything, the new product is substituting something else. So another way to look at it is, hey, I have this product. Can I find a different substitute? Can I find a different idea that would substitute this one? Okay. Combine. Combining is combining a number of products into one particular thing. Okay. See, time wise. Okay. So Swiss Army knife combines many tools into one single. Okay. It has a very high functional value because you can do many things in a very compact size. It's very reliable. That's why if you think about anybody explorers, people going to space, people going to Everest, people going to Antarctica, all of them carry Swiss Army knife. Think about your own kitchen tools. Okay. If you think about grinder, mixie, that's a super tool. You can change stuff and you can do different things with one single device. Okay. So combining, can I combine A and B to make it better than individual one? Okay. And that's a second idea that comes to mind. So when you are designing, always think about, hey, I'm addressing this need. Can I combine with something else? I have a water bottle. People take medicine with water. Can I have a water bottle that can carry medicines also? So that would be a case of combination. Okay. Adapting is, can I copy my solution from somewhere else? Humans have been here for a long time. So there's no such thing as a new idea. Everything is recycled. So there's a saying that great artists don't copy, they steal. They don't know, people don't know where they stole from. So every idea, we get it from somewhere else. You just need to figure out where we are getting it. If you think about Narayana Hrudayalaya, NH hospitals, the main reason NH hospitals is super good is it's very economical for the surgery they do, and it's extremely reliable. The reliability level is same as Cleveland Clinic, which is one of the best in United States. How do NH hospitals do the same thing as a Cleveland clinic with fraction of price? Is because they looked at Henry Ford model of car building, like assembly line. So a nurse starts the operation procedure. The junior doctor preps it up. The next level one does the main surgery part of it. The main surgeon comes, spends few minutes, does few little things and goes away. So what they are doing is they are basically looking at the time value. Is it main surgeon needed for the entire operation? Not really. And they actually copied this idea from the assembly line, but nobody thinks about that as a copy. It's much more like a innovative idea because it came from a different domain. So you always look for ideas from another domain. That's strategies adopted. Here, bullet trains, they looked at Kingfisher, bee, and biomimicry is a whole field where you are copying from the nature. And they designed it so that it reduces noise, increasing speed, it decreases power consumption. So there are a number of benefits by actually copying it very intelligently. So I'm not recommending you to copy. Don't tell your student that you want to copy. That's what you are doing with Adapt. Modify, magnify, minify. Here you are making it big, you are making it small, you are changing. So let's kind of think about Sony Walkman. Till then, people had recorders, tape recorders. Those are big, but they were not portable. Sony Walkman is what made music portable and people can hear on the fly. Then MP3 players, all of them came. But the origin of all these MP3 players, all of them go back to Sony Walkman. Okay. So think about how can I make it small, selling them. So if you think about Indian example, I can think about the shampoo in sachets. I think it starts with C. This one, Sheetal or something like that. The person did not invent shampoo. Shampoos are always sold. There's nothing new about selling a shampoo. All he did is started selling in a small packet that is very affordable, easy to buy, and easy to carry, and people can use it, throw it off. Okay, so you don't need to transport in the plane and things like that. Okay, so the design innovation there is making it easy for people to obtain, and it solved a specific point. Now selling things in sachets became very, very common. So here you are modifying, you are minifying. Minifying is making it small. You can think about making it big. Putting to other use. Let me also tell you another one here, modifying thing. Parachute coconut oil was another example, great example. Before parachute coconut oil came, people used to sell oil in a tin container. Problem with tin containers is you see a lot of dust. It doesn't look good. Now December is coming. It become cold month in India. So all the oil freezes and it's difficult to get a little bit of oil. So you heat it up, put it in hot water, things like that. Okay. So there are a lot of pain points associated, cutting, making holes, all these things. So he thought a parachute coconut oil bottle, the blue bottle, would be a very good one. It's plastic. Okay. So he came up with this idea and he wanted to sell, but unfortunately, rats love coconut oil. The shopkeeper said, hey, if we start selling this coconut oil in this bottle, the rats would make hole and the coconut oil would leak and make a mess. And he thought about it and said, hey, what can I do? Then he came up with this idea that instead of having a rectangular sharp corners, he rounded every corner of the coconut oil, parachute coconut oil. So the rat teeth, they need a sharp corner to start biting into it. If the bottle doesn't have any sharp teeth, the teeth keep sliding and you can't make it. And that's how parachute coconut oil came into existence, because he saw it. So what he did is, instead of selling oil in big one, he started selling in a small bottle, and rounded corners eliminated the pain with the rats. Okay. Put to other use. So think about recycling. Okay. Think about what can I do with the waste. Okay. In India, I see so many new stuff coming in, the plastic bottles, things like that, plastic waste used to create tar roads. Okay. You really need roads to this in a city, and instead of using the regular tar part of it, you are replacing with plastic. The other thing you can think about is the Indian. Lot of times we don't look back at our own best practices. People think about sari or pancha, lungi, these things. They're extremely interesting if you think about it. Think about a pant. If you are 30, you go to 32 waist size, you can't use it. Okay. If you want to give it to somebody, somebody should be exactly the same size to use it. So you can't really recycle a lot of Western clothing. Think about a sari. Sari, very easy to recycle. Okay. First of all, you don't need to recycle. If you increase weight, you can still fit into it. If you lose weight, you can still fit into it. Okay. And if it becomes old, you can give it to somebody else, poorer person, or you can use it for cleaning floors. You can put it on top of roof, all kinds of stuff. So think about a design. A simple design has so many interesting different uses. Okay. And that's something you need to think about. How can I put the product into repurposing? Here is much more targeted to the Western audience, which is ship containers can be repurposed to create a very interesting, innovative green buildings. They can put it there, people can live, and it's very pretty the way they did. Eliminate. As engineers, we have this tendency to add new things. If you think about Diwali shopping you did and things like that, we have, particularly in India, this tendency a lot more than America, but America also has the same tendency all over the world. You want to add more stuff. You go to buy something, they will say, hey, you buy this, you get this free. Okay. So you keep adding stuff rather than deleting stuff. Sometimes deleting features, deleting attributes, deleting the simple things are much more interesting and innovative than complex things. Okay. One of the product that came out is Flip Video. Flip Video is people in the olden days have video recorders. The video recorders have so many buttons. And you ask anybody how many buttons you actually pressed, they only say start, stop. That's it. And record. 3 buttons, nothing else. This Flip Video camera eliminated everything, made it extremely portable. Okay, it's extremely easy to use. There were only 5 buttons in total. That's it. 5 buttons, the whole thing works. Okay, and in digital records, USB drive comes here and connects to your computer. It's easy to use. It's pretty inexpensive. At that time, they priced it about $100, and they themselves said, "Hey, the phones came. This was a bridge technology between video recorders and the main phones, and they went out of business by themselves." So think about eliminating stuff. What can I get rid of and make it much more powerful? Okay. A lot of times, a good example you can give in your classroom is your projectors. Projectors have so many buttons. How many buttons you actually press? Probably 2. On, off. but all these buttons are there, and a lot of times they're hanging from the roof. Nobody can reach them. Why have so many buttons? Okay, so think about what is that I can get rid of. And I want to tie it back to what I talked. Some of you may be from the age of tape recorders. Tape recorders were very popular when I was growing up too. And there was a red button which said, if you click that, that's record. Okay. If you really think about it, how many people actually use the record button? Nobody used record. They only used to play songs. My mom was very worried that by accidentally they would record it. So she put a black tape so that by accident also people won't record. Okay. And if you are an electrical engineer, you look at it, the record head is one of the most expensive piece in that whole tape recorder. And we added because some electrical engineer said, I can record also. We keep adding these things. We never set back and say, is that feature really needed? Does it provide value? If we have said it, we wouldn't add a record head. If we didn't add a record head, it would never have been called a tape recorder. All we wanted is a tape player, not a tape recorder. Okay, so it was a wrong product name itself. So that's something that you really need to address, because we have this tendency to add stuff. Same with clocks on VCRs, DVD players, and everything. Nobody looks at knows how to set that clock. Nobody sets. Always it's 0000000 flashing. Okay. So think about, do I need that time stamp? If not, get rid of it. Okay, that's the eliminate part of it. Reverse rearrange. That means instead of doing one way, think about a different way of doing it. Okay. In the olden days, when car was being built, people used to go and work on the car. Different people go, the car doesn't move, people come work on the car. What Henry Ford did is he created the moving assembly line. In that other way, the car moves, and the guy would put the wheel, the another guy put the wheel, it goes to the next station, somebody puts the lid, they keep going one step at a time. Instead of people moving, car is moving. And we change the order in which things are happening. Particularly in engineering, a lot of things are process oriented. Think about, can I change the process so that it is much more effective? I can think about another example, McDonald's. Before that, in the restaurant, you go to the restaurant. Somebody will say, hey, do you want to, how many people? And he will find a place, comes back to you, takes you, seats you. Then after some time comes back to you and says, you want to ready to order. Okay, the menu is there. You will say, no, I need few more minutes to order. Then he comes back again and he takes the order, goes to the kitchen, gives the order. Then after some time, he picks the food, gives it to you and goes back. Then comes back, cleans the thing. Then comes back, gives you the bill. Then you may pay cash. He takes it back, gives you the change. So there's so many times he's going back and forth. What McDonald's did is, you pay the money, you get the food, you are out. So there's only one quick interaction. Remember how much time, effort we saved by changing or rearranging the process. Rearranging is really critical if you start thinking about what can I do with my process. Okay. So what we taught for idea generation is a method called Scamper. Even though it looks like one method, we have substitute, combine, adapt, modify, magnify, put to other use, eliminate, reverse, rearrange. These are 7 different tools, like 7 days a week. There are 7 different things you can use simultaneously, sequentially, iteratively to come up with really, really innovative ideas. Okay. And we also talked about several Indian examples that connect each one of them. Okay. So let me stop here. Let me go to. So what we did is we talked about how to find pains. That was the first thing we did. Then we talked about how to come up with ideas. Okay. Ideas all look good. on paper. But when you actually implement it, the ideas don't work. Okay. Let me give you an example why prototyping is important. Long time ago, I'm in St. Louis. St. Louis is the home for Emerson Electric. Okay. In the olden days, remote controls were not there. So they were trying to use a cable connection. So remote control for TV. The cable used to run from the TV to you, and you flip channels one at a time. And that was cumbersome because when people are walking, they trip on it and they fall. And they said, okay, let me eliminate the cable. And they came up with one brilliant idea. There was actually an intermediate product called Flashmatic. I'm skipping that. They came up with the idea called ultra silent sound they used. So you have a remote, you press the button, and the right tuning fork is hit from the button. And the frequency of the sound goes to the TV and it changes the channel. Okay, that worked like a charm. And the nice thing about is it doesn't need batteries at all. And so they came up with the idea, they built the prototype, they tested it, and they said this is the right product, looks like it, and they built the thing and they delivered it to in the shops. And after a week in the United States, you can give back the product very easily for the first 1 month. People started returning the product, all of them. And these people were wondering, what happened? This product worked like a charm, why are they returned? So they asked the customer. The common complaint figure out. So this one uses ultrasound to communicate to the TV. So nobody hears it when you press the thing. When I said nobody, no human being can hear it. But in US, dogs are pretty common. So the moment you change the channel, the dog starts barking. Not just your dog, the next door dog also. Okay. So that is what made people mad, because whenever you change the channel, the dogs start barking and you don't like it. So it's important to build, prototype, and test in the user environment before you actually release a product. So that is essentially our step 3 and 4. Okay. So let's talk about prototyping. So I'm going to go quickly through a little bit of prototyping, and there are many different prototypes. You can think about sketches as a prototype, but sketches are not prototype. Prototype are used for testing, refining ideas, okay, and answering unresolved issues. So you want to kind of get something from the user. Okay. So there are 3 things you can think about. In engineering right now, our prototypes, computer models, simulations are all trying to converge into one thing. So when we say prototype, you can think about a very nice computer model, could be a simulation. So here are 3 different products I put in there. Okay. First one is in 1989, Apple came up with Macintosh. Okay. Macintosh, they wanted to show people how this looks like and see whether people would like it or not. So they made this whole thing exactly look alike using foam. Okay, there was nothing except foam. It doesn't work, nothing like that. All you're trying to see is get understanding whether people would like it or not. Okay. On the other hand, these are 2 prototypes of the original prototype of Nike shoe. Okay. Nike shoe is actually uses in scamper combined technique. So what happened is Nike inventor was a football coach. One day his wife told this waffle maker got burnt, remove all the black stuff, okay, the burnt stuff. So when he was removing, he found it that it is sticking so hard, and he thought, if I can make the waffle pattern below the shoe, will it stick the same way? So he actually used the waffle iron to make the shoe and tested it out. So here he is looking at whether the shoe with the waffle pattern works or not. So it is trying to answer one question: does it work or not? Okay. If you ever want to tell the story of Dyson, prototyping to students, you must go to the website of Dyson and show them. What Dyson came up with is he was at a So this was a combination example. This one would be adopting. He was at a sawmill. He saw how the sawdust was separated using thing, and he copied that solution into a vacuum cleaner. So it is adapting from Scamper. So I'm tying it back to the previous section. Okay. So he built with a cardboard. Once the idea came that night, next day he checked it out and it worked. And he had to build few thousand models before it became perfect, but prototyping helps you to keep answering questions. So this model is to see whether the idea works or not. So all of them are examples of prototyping. Okay. So when you are building prototypes, you may get insights or you get feedback. Hey, this is easier to build. You may change it back. And you may do testing, and then you may change the context. You may get new user insight, and you go back. That's why I told you it's a pretty iterative process. Okay. Prototyping is quick, easy, inexpensive way. Okay. So you want to make sure that you are not building something that is the final product. Prototype should be quick. Okay. Should be easy, inexpensive. It may not look really good. It has to answer the question you are interested in. To converse and interact about your concept and learn from your customers. So you want to take this prototype and say, do you like this particular USB connector? That's essentially what you are trying. So for that, you don't need to build the prototype. Prototyping became much more easier with 3D printing technology. We are using 3D printing more. And the risk is to avoid, once you build, you release it like the Emerson release of the remote control. You don't want returns. That's what the prototyping is about. Okay. And I'll skip few slides. There are primarily 4 types of prototyping activities you do. One is look and feel. Another is raw, implementation, integration. So here we were doing, this was our university doctors, SLU doctors. Okay. This was a project that I was doing. We wanted to see whether 3D printing, this was almost a decade ago, more than a decade ago, is useful for surgery. And they were using this to figure out, hey, this was actually how brain surgery, what nerve they have to operate, things like that. So they are basically using like a role thing to understand how they are going to do the actual surgery. Okay. Look and feel prototype. Okay. They give concrete user experience, and it tells you, hey, this is how the heart is. This is a human heart. We 3D printed this one. This is our lab. This was also our lab. We 3D printed both of them. This was a long time ago. So before heart surgery, gives you look and feel. Think about, you are going to a surgery, and if you think about what the doctor sees a scan which shows you along horizontal axis, they can go up and down. Along vertical axis, they can go up and down. So they get 2 of these pictures, and then they go left and right, another plane. And in their mind, they construct how your heart is. And we teach students 3D graphics, particularly mechanical engineering faculty. You know how well our brain works for regular squares, rectangle. Think about heart. Whereas this one, they can actually look and feel this prototype and say how I'm going to connect a duct or a blood vessel from here to here, or whatever they need to do. So that is look and feel type prototype. Implementation prototype. Our students build go to BattleBot. These are done by our students. Okay. So BattleBot, before you actually build the main one with titanium pieces, things like that, we actually do it using CAD model. Okay, this is how it is. This is how we will put the components, everything. Then we actually make a prototype with wood. Okay, so this one we actually run it, make sure that it is easy to assemble, that it works, what kind of problem we get. We fix all of them before we actually building the final thing with titanium pieces. Okay. Integration models, they represent complete experience. They basically look at right look and feel. They make sure that everything is right weight and things like that, so that you do it before you mass produce stuff. Question? Okay. This particular one, we had a project where we had to drop a number of sensors from the airplane, and all of them have to come slowly down. As they're coming down, they collect the data. So we need to reduce the speed of it. Okay. So we looked at different one. Parachute is the first one that came to mind, and like a wind turbine kind of thing, when it is coming, it rotates, it reduces the speed. But we found that this seed, in India, you see this seed that goes around, twirls around as it comes down. They call Samara seed here. And we got this idea from this, and we copied it, made it with foam, and we put these lines so that they can rotate it. Our sensor is right here. And we actually built this whole thing, approximately how it would finally function. Because we had to release thousands of these at one time. It's important they have to be stackable. These were not easily stackable, and this was much more easier to stack. So we ended up with this concept. So this is a prototype you do just before releasing. When we talk about prototype, we talk about low and high fidelity. Low is cheap, inexpensive. We do it in early stages. We do with paper, post-it, clay, things like that. High fidelity, you do it at the end. That's expensive. That looks much better. Things like that. So this would be considered high fidelity prototype. Okay. We can do horizontal prototype, vertical prototype. Horizontal means you have all the features of the product. Okay, but most of the time, most of the features work. There's one or two critical features that you want to make sure that works. In that case, we make sure that that particular one, you build it out completely so that everything is good. So we do this vertical prototype. Okay, if you put this thing, low fidelity, early stages we do. Okay, horizontal, we understand the scope, user requirements. Vertical, you kind of look at, hey, which button they like to press, user interface, things like that. We do vertical. Okay, so high fidelity size is the later stages. Okay, here we are doing integrative is you want to show the entire system. Here you want to show a key part of it. Somebody is not sure how this security lock works, and that only that part you want to show in your software. Other parts are easy, people will believe you. Something that is harder one, you do it. Okay, typically we think about steps. We define what is that we are trying to find out from building this prototype before we build it. Most of the time people like to build stuff without knowing why they are building. Then we select what kind of prototype we want. Then we build it. When we build it, we want a rough, because rough one invites question. If it is polished, people say, hey, I want to praise it. I don't want to ask questions. Okay, keep it simple. Okay, so I'll skip few things. These are the initial prototypes some of our students built. This one is for a soccer shin guard. Okay, here is a shopping cart, a alternative design. The initial one you can see here is our sketch. Here is our more detailed sketch. Here is a prototype. Prototype is built with straws. This is initial one. This one they were doing a space heater. The space heater so that it doesn't catch as fire. This is the shape. And this is made out of foam and a cloth. There's no heater inside, nothing like this. This is how you can show it to the user. And you ask, hey, is this a shape? Is this something you can use? Okay. Here is a functional prototype of a solar cooker our students built. This one, the goal was they should be able to boil the egg. This was initial prototype. This one is the final. You can obviously see the final one looks much nicer, shiny and everything. This one is aluminum foil. You can clearly see the progression from here to there. Okay. In the interest of time, I'll skip the prototype part of it. I think you got enough of prototyping. Let's do one last thing. Testing, you want to test the product with different stakeholders. You want to see what their views are. When we say stakeholders, you can take the prototype to the shop floor guy and say, hey, if it's easy to build, what should I change? You are basically getting information from the shop floor. Or it could be a user. It could be a person who's selling the product also, okay, who is packaging. So there are number of stakeholders, and then you interpret the result. We were testing this particular room heater, and this one, the biggest problem with room heaters is people accidentally leave stuff on this, and it can catch fire because air is blocked from the bottom or the top and things like that. And this is the form we were using so that air doesn't get blocked at the bottom, and we wanted to see whether it works or not. So testing is an opportunity to refine and improve concepts. A lot of times we think that we are testing to make sure that nothing goes wrong. We are not trying to test to make sure nothing goes wrong. We want to find out what can go wrong. So the attitude of testing is not to find everything is good. The attitude is what can go wrong. And that's the most important. Okay. So you want to engage, observe them, and find unexpected insight. Okay, what can be going wrong? We always tell, test early, test often, fail fast. You learn from it so that your product doesn't fail. So always testing start with a prototype. So when you are building the prototype itself, you are asking a question. What question does this prototype answer? Don't build a prototype unless you know what question you are trying to get answered. Okay. So identify what task you want the user to do. It could be a hypothesis testing. You want to see where they would put it, how they put it, and things like that. Okay. So you define clearly, start the question. So the question we had was, does the product that we had, this space heater, fit in the home? Okay. Then we thought about different participants. You could think about design teams. Initially, you can do colleagues, but really we wanted to find from the users, expert users. Okay. And we wanted to ask open-ended questions. Sometimes people say predefined tasks. For example, if you had developed the app, if you are using a map PLS or some new maps app, you tell that, hey, you want to share your location, and here is app. How would you go about sharing the location? You want to see how the user goes about doing it. So you are defining a task. Open-ended means you give the app and say, hey, play with it. See what you can do. Okay. Script. You tell what you want the person to do. Then you present the design, you tell the thing and say, hey, do it. Then I'm going to skip a little bit. And this is what I want to spend time. Okay. And this is the technique I always use. This is not mine, it's Stanford one. Okay. Ask them what they wish. Most of the time, all humans want to hear good things about your ideas. Okay. If you think about you using AI, ChatGPT, things like that. It always tries to please you. It wants to make you happy. Okay. Same way when you are testing, we always want to make sure that we are happy. And unconsciously, your users also trying to make you happy. Okay. So get that out of your way by saying what I like. So I like tells these are the things I like about your design. And people don't want to say I don't like this, okay, because it may unconsciously hurt the other person. Okay. Make them frame it as I wish the cup was a little bigger. I wish the cup was more insulating. I wish it doesn't leak. I wish it's sustainable. I wish. So ask them to say what are their wishes. Good ideas build on the wishes. Second thing I want to kind of go back is your wishes are your pain points. They're telling in a positive way or negative way. Okay? You also ask them what if question. What if the cup is really small? Okay. So what if things that are unanswered questions in their mind? So you give them white paper with 3 blocks. I wish, I like, what if? And they can fill that questionnaire and you bring it back and you analyze. Okay. I like is patting on your back and saying that, I did all these things. My users liked it. But don't take that too much to your heart. The thing that you want to focus on is what is that they wished, what is that they would like to see if they wondered about a product. So that is essentially what you do with testing. Okay. So we have about 8 minutes, so I'm trying to wrap it up with an integrative example, which I promised. So what did I tell you so far? We talked about brainstorming, identifying pains. Then we come up with ideas. We use Camper. We tell prototyping. There are 2 things you think about: high fidelity, low fidelity. High fidelity is almost at the end of the design process. Low fidelity is in the initial stages. Horizontal prototype, which means you show the entirety of the product. A vertical prototype, a small portion, user interface, things like that. Then you test with the users. When you test with the users, I recommend, I like, I wish, what if, and use that framework. It will provide you fairly good insight. What I'm telling is one of many methods. I'm not telling all the methods. We don't have time for that. Okay, then we'll be here forever. And let's say we want to do a smart water bottle, and we go through the same process. Okay, so first stop is what are the pains storming? What are the pains associated? You may think about people forget to drink water throughout the day. They drink only whenever they are thirsty. That may be too late. We want to coach people to drink more water. Okay. And you can think about gain part of it. If you think about people with diabetes, more water they drink, it flushes more sugar off your thing. It will have healthy benefits. Okay. People say 8 cups for water. Not many people drink it. Okay. Bottles, people are not worried if water is clean. Tap water concerns, particularly in India, people say, hey, this water may not be good. So that's a concern. Bottles leak in a bag. Leaking is a problem. And if you have cold water bottle, sometimes water condenses are outside if it is a humid day, and that's a pain too. And water bottles are hard to clean. Okay. Sometimes they smell plasticky. We don't know whether plastic really bleached, but the smell is there. Okay. No way to track. So there are many, many problems. You can pick 1 or 2 focus pain. So I want to say, I forget to drink water throughout the day. I'm a busy person. I don't have time. I'm teaching class after class and I forget. I want to make sure I drink. So I want a smart water bottle that reminds me to drink all the time. So what I did right now is I looked at all the pain. I defined 1 pain that I'm going to address. You may ask the question I haven't formulated creatively, The goal right now is not formulating creatively. I just want to show you the overall process. Forming creatively would have been much better. Then you can think about our scamper method. You can say that instead of plastic, I will have glass bottle, or instead of plastic, I'll have stainless steel bottle. So I can change that. I can make it glass transparent. That way you can see through the glass. I can make bottle carry medicines at the bottom. Okay, I can have buttons, things like that give feedback. Okay, every time you open, the cap sends a signal. Okay, I can track intake, bottle tracks and prompts automatically on a buzzer or something like that. So I can look at each one of them, come up with idea. There are 7 ideas here, and each one substitute may itself give you multiple ideas. Okay. Then you pick something and say, hey, I'm going to prototype it. So take a plastic bottle as a base. You may paint it stainless steel. Okay. And put a smart cap on the thing. You may use markers, paper sleeve, whatever you want to do. Show this LED light, blue LED light on the top. Say that's what UV purification. So the goal of prototype is build very quickly to show it to the user and say, is it the right size bottle? Does it solve your problem? Get some feedback from them. Okay. Then you ask them to fill out what is that you like, what is that they wish, what if? Okay. What if it could sync with my fitness tracker? Okay. So you're walking higher a lot, you can drink more water. Or what if it tracks with my weather app? That way, if you are hot, it reminds you more often. If it is cold, it tells you drink less. So it becomes smarter. Okay. How do I different types of beverages? Can I make it? What if it is insulated so you can take hot tea also? Things like that. So essentially, what we went through here, when you are doing bottle, you start with brainstorming, you think about different ideas, then you prototype, you test with users, you get insights, which would change your ideas a bit. Okay. And then come up with the bottle. So you think about plastic bottles. How many different types of plastic bottles we could have? So here are some bottles that I found very interesting. This one is a collapsible bottle. So it addresses a pain. The bottle doesn't fit if you're traveling. This one fits. This one kind of makes an interesting design. This one, when you fill the water bottles, it expands, otherwise it contracts. Here, aqua tissue that uses combined technique. That means that if it is hot, you sweat a lot. So you can take the tissue on the top, put some water, clean your face. This is another collapsible one. Okay. Here is a substitute. You use paper, so it's completely disposable. Here is a bottle. Every time you drink, a smart one, you rotate it. It tells you drank, how much plastic you save, things like that. Here you don't need to carry. It goes on your wrist. And here they're used after the thing. People, they can use it for construction toys, things like that. Okay. So that comes exactly at 9:20, and I told that I was told give 10 minutes for question and answers. So I just want to end this with this note saying that, give me 1 second. What we did today is the design portion, the brainstorming, camper. We showed the prototyping testing, and I showed you an example of smart water bottle, which takes you through all the steps. Okay. With that, I open up question answers. If you have any questions, good time to ask.
Thank you so much, sir, for such a wonderful session. It was really very informative, very engaging, and full of examples. I hope all the participants have enjoyed today's session, and the forum is open for you, question and answers. So participants are requested that they can feel free to ask their questions.
Hello. Someone is
Go ahead.
asking in text box, can you
Yeah,
suggest
yeah.
some AI tools for design thinking?
Some AI tools for design thinking.
Design thinking.
So there are lots of AI tools for design thinking, but the best ones are actually using any of the chat GPT thing. The more important would be the prompt portion of it. The prompt portion is if you tell that walk me through a life of a athlete or a tracker. I'm an avid tracker. Walk me what I would do in a day. So they can walk you through a user journey map. Things like that are much more useful than things that would do the 3D modeling part of it. Okay, so most of it, the goal is to provide insight. Scamper technique, you can actually automate. We have several prompts that help you to get good ideas using generative AI. So we use prompts more than tools. I hope that answered your question.
Yes, sir. Thank you, sir. One more question is raised by Ramchandran S. How can design thinking encourage creativity and problem solving skills among students in non-technical disciplines? Can I repeat, sir?
Yeah, I got it. Thank you.
Yes.
So
Yes.
the primary thing I think is design thinking. There are two parts to it. Empathy is understanding other person's feelings, pains, problems. So it doesn't matter. You may be in customer representative or things like that. The ability to understand other people, come up with simple ideas is universal. Okay, and that's applicable in all domains, technical, non-technical domain. If you are in sales, understanding what the other person is looking for is much more important. So the focus become outward. Design thinking helps you with that. The second part of it is they come up with very innovative ideas. So as a change, if you think about design thinking, step one thing back. I see leaders, entrepreneurs, artists, designers, all of them have very similar values and thinking. And design thinking focus on the value. If you get a job, you have to understand what is the value I'm bringing to the organization. That means how am I helping the organization to make money? If you don't help the organization to make money, then you are useless. You'll be out of job. So that ability to understand the value, that's where I started off, really helps you to become better in your life.
Okay. Thank you, sir. I hope we cleared all the doubts. Any more questions? Hello, participants. Anyone ask some questions?
If you have no questions, that's the end of the thing. Thank you very much and
Yes, sir.
appreciate and hope I will see some of you in person in one of the my workshop, other one. If you have any other questions, feel free to reach out. I will share the slides with the facilitators. They can in turn share it with you. Okay, thank you. Have a wonderful day.
Thank you, sir. Thank you.
Thank you so much, sir.
Thank you.
Yeah, can I just say a quick thank you to Dr. Sridhar, this Raghu Champari. He very quickly accepted within days, couple of days,
Yes, sir.
to oblige my request because of Dr. Larry's health situation, his wife's health situation. So I really want to personally thank Dr. Sridhar and also the organization, your school, to allow us to make this change very quickly. You know, that's what he's talking about. nobody likes to change, right? Except wet baby, they say. But like Siddha is very. I was listening to part of his lecture today. It's wonderful, and I want to personally also thank him and thank you all.
Thank you very much.
Sir.
Yeah.
And always remember that just like I accepted, every time God provides us with the opportunity to make a difference. And I'm hoping that whatever you listen, some of these you take it and make a difference in your students' lives. Okay, thank you.
Thank you so much, sir, for
Thank
an
you, sir.
enlightening session, and thanks to all the participants. Tomorrow, all the participants are requested that tomorrow, sharp at 6 p.m., join the session. And I wish good night to everyone, and bye bye.
So, Bhumikati, you're going to be here,
Yes,
right?
sir. Yes,
Oh.
I am sir here.
Okay, good.
Hello, sir.
Yeah, that's okay.
We can just finish this left
Yeah,
the meeting,
sure.
and again we can create within a 5 minutes. We will again share the link with you, sir.
Yeah, it
Hello.
went very nice. So, can we use this platform or no?
What, sir?
Can I use this platform? I mean, this.
Yeah, yes.
Okay.
But
I'll
there
wait
are
for it.
participants
Don't
still
waste
are
your
there.
time. Yeah.
Yeah, that's right. Once we finish this this meeting, and we can recreate the meeting. Okay. Yes. Within 5 minutes, I will update you, sir. Thank you, participants. We will meet you next session.